So let's talk first about your discussion of neutral theory. I would say I saw the most confusion about this one. The confusion mostly centered on the question, well, at a fundamental level, what are neutral models? But more specifically, do neutral models use your own data somehow, but like in some different way? Or do neutral models just use a computer simulation without your real data? And the answer is yes. So, of course, that's a strange way to answer it, but your confusion about what neutral theory is warranted. Neutral theory is not something that's precisely defined. Neutral theory, in terms of Hubbell's neutral theory, means different than neutral models that are used in landscape ecology, and there's different kinds of neutral models. So the term neutral theory or neutral models can mean many different things. So when you're talking to somebody about some neutral theory or neutral models, you need to ask them for clarification about what they mean. Do they mean for example, a neutral landscape model that's just based upon some sort of a computer simulation where there's no real data involved? Or do they mean something more like Hubbell's neutral theory, where real data is used, but at a very minimal level? So, for instance, Hubbell's neutral theory would count the number of individuals of different species. So that's real data. I mean, that's data that you would have collected, how many individuals you have of different species in a locale. And then Hubbell's neutral theory would forecast how many individuals how those individuals should be spread around throughout the landscape, depending upon the numbers of those individuals. And it would make forecasts about the rate of growth of the different individuals based upon their starting numbers, but nothing else. So Hubbell's neutral theory would not assume that the species are in any way different at all, that they differ in their niches or in where they're found in some other way, by some geographic barriers. Hubbell's neutral theory can incorporate differences in growth rates among species, which is not very neutral at all. And you're right to think that it's not very neutral at all. This term neutral theory is not a good term in my point of view. It's not precise at all. And you are right to be confused. I didn't invent these terms, of course. I'm just trying to show you what is out there in this field of study. And one of those things is neutral this, neutral that, neutral theory, neutral models. And you're right, they're not well defined. So you need to ask somebody if they refer to neutral this or that. Are you referring to a complete computer simulation where fractal geometry was used to make the landscape map? Or are you referring to predictions about species distributions on the landscape based upon the numbers that were observed? You have to try to ask for more information. And none of this is very neutral, because if you're talking about living things, there is biology going on. Living things are alive and they move and they reproduce. So what does it mean to have a neutral model? Well, I liked a lot of the answers that you all gave in your discussion posts. I'm trying to think of some of them here. That neutral theories are simpler, that they make fewer assumptions, that they make as few biological assumptions as possible, that they use as little data as possible. I think that's the flavor of what people generally mean when they talk about neutral theory, neutral models. But there's a reason that you're unsatisfied. It's not a well-defined concept, and it's used differently by different people. So be aware of that. There was an interesting comment by one of you that if two models show the same results, doesn't that make them the same model? And no, that's not necessarily the case. So keep in mind what a model is. A model is mathematical equations that give you some outcome. And you can have a very complicated mathematical equation where the answer is 4. You can also have a very simple mathematical equation where the answer is 4. So 2 plus 2 is 4, but so is, 3 times 4 to the 8th power minus the square root of 9 million plus 86.4 divided by the log of 97, whatever. So you can have different equations that give you the same answer. And remember that a model is an equation. You've got data, and you have an equation that relates, for instance, your x variable to your y variable, according to some equation that tries to predict your data points. That's what a model is. And you can have a simple model that's used to predict your data points, or you can have a complicated model that's used to predict your data points. But a simple model and a complicated model can both predict the same result. For a given input, a simple model and a complicated model can both predict that the answer is 4. 4 meters, 4 whatever. You name it. So no, just because 2 models show the same result doesn't mean that they're the same model.